In this lesson, we're going to be graphing quadratic functions of the form f of x equals ax squared plus bx plus c, and finding maximum and minimum values of quadratic functions. I'm going to zoom in here. Graphing f of x equals ax squared plus bx plus c. The graph opens up when a is greater than 0. The graph opens down when a is less than 0. The y-intercept is c, and that makes sense because the y-intercept is the value of y when x equals 0, and if you plug in 0 for x here and here, both these terms drop out, and you just get c for your y-intercept. The x-coordinate of the vertex is negative b over 2a. You'll see why that's the case in the next section, but for now, all you need to remember is that the x value of the coordinate is x equals negative b over 2a, which is also the axis of symmetry right here. Okay, and then to find the y value of the vertex, you would just plug this value into your function. For example 1, we're going to find a, the axis of symmetry, and b, the vertex of the graph of f of x equals 2x squared plus 8x minus 1. So first to find the axis of symmetry, well, I remember that for the axis of symmetry, I have the equation x equals negative b over 2a. So I'm going to use this equation and identify my a and b value from my function and then plug these in. So my a value of my function is going to be 2 because that's the coefficient of the x squared term. And then my b value is going to be 8 because that's the coefficient of my linear term or my x term. So anyway, I'm going to get x equals negative and then 8 over 2 times a, which is 2, which is negative 8 over 4, which is equal to negative 2. So my axis of symmetry is going to be x equals negative 2. So that's part A. Now for part B, what I'm going to do is I'm going to take my x value and then plug it into my function here, so negative 2, and then I get f of negative 2 equals 2 times negative 2 quantity squared plus 8 times negative 2 minus 1. Well, negative 2 squared is 4, and then 4 times 2 right here is going to be 8. And this is going to be minus 16 minus 1. If I combine my like terms, I'm going to get negative 8 minus 1, which becomes negative 9. So f of negative 2 equals negative 9. So if I go back here, the vertex is going to be the ordered pair negative 2, comma, negative 9. So this is the vertex, negative 2, comma, negative 9. And then this is the axis of symmetry, x equals negative 2. And now we're done with this one. For example 2, we're going to graph the function f of x equals 3x squared minus 6x plus 5, and then describe the domain and range. Well, whenever I am graphing a function, I want to make a table of values, but what I want in the middle of my table is the vertex, the xy pair, that's the vertex. And remember, to find the vertex, I need to use x equals negative b over 2a. Okay, well in this case, b is equal to negative 6, so this is going to be negative 6 over 2 times 3. So this gets 6 over 6, which is 1. So my vertex x value is 1. And then to find the y value, I'm going to plug it into the function. So if I take this x, plug it in here and here, well, I'd get 1 squared times 3 is 3. And since there's multiple steps, I'm just going to write it out. So I get 3. And then minus 6 times 1 is just minus 6, and then plus 5. And then I can just combine these terms. So 3 minus 6 is negative 3, plus 5 is 2. So my y value is 2 when my x value is 1. So that's where I'm going to start my table here. So x and then f of x. I'm using f of x and y interchangeably here. So I'm going to put my xy pair here, so 1 and then 2. And I'm counting by ones on my graph, so I'm just going to go 2, 3, and 4. And then 0, negative 1, negative 2. All right, and remember, this is also the axis of symmetry, so I could draw a dotted line right here to show that this is symmetrical, or I could just use that fact to help me fill in my table quicker. Anyway, now I'm just going to plug in some values quickly. So I could plug in x equals 2, but I'm actually going to plug in x equals 0 because that's going to be the easiest. So if I plug in 0 here, this term drops out, and I just get 5. So this will be 5. And then since this is my vertex, and the distance between 0 and 1 is the same distance as 1 and 2, this is also going to be 5. Okay, now I can either plug in 3 or -1. I'm going to plug in -1. So if I do this again, I get -1 quantity squared is 1 times 3 is 3. And then -6 times -1 is +6. And then +5. Well, I'm going to get 9 plus 5. That'll be 14. That's not going to fit on my graph, but I'm going to put it here. Anyway, now I'm going to plot my points. So first I'll plot my vertex 1, 2. That is right here. Then my next point is going to be 2, 5. And then I will draw the symmetrical point, which is 0, 5, which happens to be the y-intercept here. And then that's it. That's all that fits on this graph, because 3, 14 or -1, 14 is not going to fit. Now I'm going to draw my smooth curve as best as I can through this. Anyway, I've successfully sketched my parabola. Now I need to describe the domain and range. Well, remember, the domain is just all the possible x values, and the range is the set of all the possible output values, or the f of x values, or the y values. So my domain is all real numbers, because I can plug anything into x here. So domain, all real numbers. And then my range, well, if you look at it, the lowest y value is the vertex, and that is at the ordered pair 1, 2. So the y value here, or f of x value here, is going to be 2. That's the lowest one. Every other f of x value is going to be larger than 2. So I'm just going to write an inequality, which is going to be f of x is greater than or equal to 2. Because this describes the set of all of my output values, all my y values. Anyway, I've successfully graphed this function and then described the domain and range, and now we're done. Maximum and minimum values. The y-coordinate of the vertex of the graph of f of x equals ax squared plus bx plus c is the maximum value of the function when a is less than 0, or the minimum value of the function when a is greater than 0. So the only difference is here I have a being positive, and if a is positive, I have my parabola up like a cup. And if a is negative right here, I have it down like a frown. And if it's down like a frown, the vertex will be the maximum point, and if it's up like a cup, the vertex will be the minimum point. For example 3, we're going to tell whether the function f of x equals -4x squared minus 24x minus 19 has a minimum value or a maximum value, and then we're going to find that value. Well, I can tell right away by looking at it that's going to have a maximum value because my a coefficient here is negative. This is -4, which means my parabola is going to be down like a frown, which means it's going to have a maximum point. The vertex is going to be the largest y value on there. And then to find this maximum value, what I'm going to do is just find the ordered pair for the vertex, and that y value is the maximum value. So I'm going to do my x equals -b over 2a, because this is how to find the x component of my vertex. So I'm going to plug in -24 for b and then -4 for a. So this is going to equal parentheses, -24 over 2 times -4. A common mistake is if there's a negative coefficient to forget this negative sign as well. Make sure that you're always plugging in your numbers with parentheses because this negative and this negative are going to eventually cancel out. So anyway, when I simplify this, I'm going to get positive 24 over -8, which equals -3. So I know that -3 is the x value of my vertex, but in order to find the y value of my vertex, I need to plug this value in to my function. So I'm going to have f of -3, and this is going to equal -4 times -3 quantity squared minus 24 times -3 minus 19. Now I'm going to simplify. So -3 quantity squared is 9, so I have -4 times 9, and then -24 minus 23 is going to be plus 72, and then minus 19. And then I'm going to multiply this out. -4 times 9 is -36. And then might as well do this, 72 minus 19. Well, 72 minus 20 is going to be 52, and then I'll add 1, which will give me 53. And then last, I'm going to do -36 plus 53. Well, that's the same thing as 53 minus 36. If I borrow I get a 7, this is a 4, and 17. So f of -3 equals 17. So this right here, 17, is my maximum value. So part A was we have a maximum over a minimum value, and then part B, that maximum value is 17. Anyway, I've successfully found the maximum value, and now I'm done. For example 4, the suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by y equals 0.000098x squared minus 0.37x plus 552, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? Well, to figure out the lowest point of this cable that's like a parabola, I can just find the vertex of that, and then whatever that y value of the vertex, that's going to be the lowest point here. Because if you see, this parabola is up like a cup, so I know that my parabola is going to have a minimum value right around here, and I can also tell that because my a value is positive, although it's very close to 0. Anyway, I know the x value of my vertex is x equals -b over 2a, and then when I plug my values in, I'm going to get -0.37 for b, so I get negative parentheses, -0.37 over 2 times 0.000098. Okay, now you could do this out if you wanted to, but I'm just going to use a calculator to make my life easier. So I'm on Desmo Scientific, and then I'm going to plug in 0.37, because if you remember, these negatives cancel, and then over 2 times 0.000098. Okay, and then I get my x value, and I'm going to round this to the nearest whole number, and I get 1,888 about. So I'm going to go back here and rewrite x is about 1,888. Now, I could plug this value back into my function, but technically to be a little bit more accurate, I can actually just take this entire answer and plug it back into the function. So in a new line, I'm going to write my function, which is 0.000098 times x squared. Well, I'm just going to copy this in here and then square it. So that's my first term. And then I have minus 0.37 times x, but my x value is this, about 1,888. And I'm going to paste this again, and then close that parentheses, and then plus 552. And I get 202.7 blah, 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 blah. So this would be the exact height, but I'm going to round to the nearest foot here, and this is going to be about 203 feet. So if I go back here, I know that f of 1,888 is approximately 203 feet. Anyway, we've successfully found the vertex of this parabola, and we've used it to find how tall the lowest point of the cable is above the water, and now we're done. For example 5, a group of friends is launching water balloons. The function f of t equals -16t squared plus 80t plus 5 represents the height in feet of the first water balloon t seconds after it is launched. The height of the second water balloon t seconds after it's launched is shown in the graph. Which water balloon went higher? Well, first of all, I want to show you guys this awesome picture of these guys launching the water balloons. But anyway, let's look at what we're dealing with. So I have my function in function form, and then I have a graph of the function here. Well, I can tell that the highest point of the second balloon is right around here. So this is right around where the vertex is going to be. And if I'm counting by 25 each space, then this is going to be a little bit over 125, I should say, 125 feet. So maybe like 130-ish. So I'm going to put that there. Now to figure out which water balloon went higher, and if this is about 130 feet, now this is not exact, but that shouldn't matter. What I'm going to do is find the vertex of this function. If you see, my a value is negative here, so I know that this parabola is going to be down like a frown, so I'm going to have a maximum value. So to find the x value of my vertex, I'm going to have negative b over 2a, so x equals negative b over 2a. And then I'm going to plug this value back into the function to find the highest point that the water balloon was at. Anyway, I'm going to plug my values in. Well, b is 80, so I'm going to get negative 80 over 2 times a, which is negative 16. So this becomes 80 over 32. The negatives cancel. Now I'm going to simplify my fraction, so I know I can divide an 8 out right away. So now I'm going to get 10 over 4, and I know I can divide out a 2 from there, which is going to be 5 over 2, which is the same as 2.5, okay, or 2.5 or 5 halves, whatever you want. Anyway, now I'm going to take this and then plug it back into this function to find the y value, and then I want to see if this is taller than our approximate 130 feet. So anyway, I'm going to get f of 2.5 equals negative 16 times 2.5 squared plus 80 times 2.5 plus 5. Okay? Anyway, I know 2.5 squared is 6.25. Then I'll bring down this negative 16. And then 80 times 2.5 is going to be 200. And then plus 5. Okay, anyway, if I do this multiplication out, this is the same as negative 16 times 6 1/4, which is the same as negative 16 times 25 over 4. You could use decimals if you wanted to, but actually fractions are looking easier in this case. So anyway, now I'm going to cancel this 4 with the 16. So this is going to become a 4. So it's going to be negative 100. And I'll bring down the 200. And then I bring down the plus 5. Okay, so I'm going to get 100 plus 5. And that's going to be 105. So I get f of 2.5 is equal to 105 feet. Now, this is not close enough to our vertex up here, which we know is about 130 feet. We know it's at least over 125 feet. So anyway, we know that the second balloon goes higher in the air. So I'm going to write that down. So the second balloon goes higher. And now we're done with this one.